Okay, so if the teacher knows from experience that 60% of his students will have their ties done up correctly when next they appear in his class, find the probability of that. I'll settle for 60%. All right, the next 3 students will have their tie done up correctly and the following 3 will not. So if the next 3 students in all have got their tie done up correctly, that's just 0.6 by 0.6 by 0.6. If the next 3 don't, well, the probability of not having their tie done up is 1 minus 0.6, which is 0.4. So this was a specific order. So 3/5 to the power of 3 times 2/5 to the power of 3. Well, that's the same as 6 to the power of 3 over 5 to the power of 6, which is approximately 0.2765. All right. If, however, 3 of the next 6 students will have their ties done up correctly, that can be in any order. So again, we've still got our 0.6 to the 3 and our 0.4 to the 3 because there's going to be 3 students with their tie correct. But the 6C3 out the front is the combinations, the number of ways we can get 3 students to have their tie done up correctly. All right, so, and that's that significant part of the binomial expression, isn't it? All right. So 6C3, just to refresh our minds, 6 by 5 by 4 over 3 by 2 by 1, 3 2s are 6, so I get left with a 20. 20 times, well, that doesn't look right, 20 times the answer above is equal to 0.2765, which means our previous answer, if my pen comes in, is in fact equal to 0.0138. Okay, so note that correction. All right, what about the probability of at least 3 of the next 6 students will have their ties done up? Well, at least 3 means you can have 3 or 4 or 5 or 6. Okay, so on our calculator, and we'll look at a range of ways we can do that, it comes to 0.8208. So quite possibly at this stage, you might just do very quickly 6C3, 0.6 to the 3, 0.4 to the 3, and then I've got 6C4, 0.6 to the 4, 0.4 to the 2, 6C5 for 5 correct, 0.6 to the 5, 0.4 to the 1, and 6C6, 0.6 to the 6, 0.4 to the 0. So you can put it all in your calculator and get 0.8208. But we will look at a better way to do that and a quicker way to do that very shortly. Finally, exactly 3 of the next 6 students will have their tie done up correctly, given that at least 3 of the next 6 students have had their tie done up correctly. So clearly it's a given statement, so it's conditional probability. So I'm looking for exactly 3 given greater than or equal to 3. So my rule says that's equal to the intersection of exactly 3 and x is greater than or equal to 3 over the probability that x is greater than or equal to 3. So that top line, what's the intersection between exactly 3 and greater than or equal to 3? Well, what satisfies both? Well, only x equal to 3 satisfies both. So that answer over the probability that x is greater than or equal to 3, actually the previous 2 answers, 0.2765 over 0.8208, and that gives me 0.3368. All right.